In this video, we're going to look at some measures of central tendency. I'm starting with a really basic distribution that contains the numbers 1, 2, 2, 4, 5, and 7. A measure of central tendency is also called an average. Most of us think of an average as adding up all the numbers and dividing by how many we have, but average really just means some kind of a number that represents the numbers in the middle. So as we work through these different measures, we're going to go ahead and think about what that means, that term average. Let's start with the mode. The mode is the most frequent data value, and in our list the mode is equal to 2. Some distributions have no modes, some distributions have multiple modes. For the second one, let's take a look at the mean. The mean is what most of us tend to think of when we think average. For the mean, we add up all of the numbers and divide by how many we have. So we're going to add these numbers up. And we're dividing by 1, 2, 3, 4, 5, 6, and we'll divide by 6. Symbolically, this is capital sigma, which is the sum of all of the data values. Those data values are denoted x, divided by the number that we have, which is n. So I'm just going to be quick here and grab my calculator, and I'm adding up 1 plus 2 plus 2 plus 4 plus 5 plus 7, and I will divide that by 6, and we come up with our mean, which is 3.5. Next we have the median. The median is the middlemost number. Notice how I have all of my numbers here in order. They have to be in numerical order, otherwise you can't find the middlemost number. Well, the middlemost number here actually doesn't exist because I've got 1, 2, 3 followed by 3 more. So the middlemost number would actually land right there. So in order to find a median, when I have an even number of values, I need to just take the two middle numbers and average those, or find the mean of those. So for this case, well, it's going to be 3, right? You can look at that. 3 is between 2 and 4. But if it was a tougher one to calculate, you would find the mean of the two middle numbers. So I do 2 plus 4 divided by 2, 6 divided by 2, and our median is 3. Let's see, so we can do maybe one more here. Let's take a look at the mid-range. The mid-range can be thought of as a measure of central tendency, but it can also be thought of as a measure of variation, which gives me information about the spread of data. But because it is both, I'll go ahead and do it here. The mid-range takes the minimum number plus the maximum number and divides it by 2. So it's really a mean of the minimum and the maximum numbers. So I'm looking for that middlemost number if I didn't know what all the numbers in between were. So 1 plus 7 divided by 2. So 1 plus 7 is 8 divided by 2, and my mid-range is 4. So we've done a simple distribution. In our next example, we're going to look at a grouped distribution. So this is a group distribution. I've got classes, so these could represent ages or salaries or any other kind of information. 10.5 to 20.5, I have 7 values that fall into that category. 20.5 to 30.5, I've got 3 in that category, and so on. F stands for frequency. I'm going to repeat my measures of central tendency for this grouped example, starting with the mode. The mode is going to be the most frequent data value. I don't have individual data values, I only have classes. So instead of the mode, we're going to instead find the modal class, which is the class with the highest frequency. Well, that happens right here at 7. So the most data values lie in the class 10.5 to 20.5. So my modal class is that first class, 10.5 to 20.5. Next, we want to take a look at the median. Again, I don't have individual data values that I can line up numerically, so we're going to find the class that contains the median. that contains the median. To do this, I need to know how many data values I have. So I'm going to take my data values, 7, 3, 2, and 6, and I'm going to add those up. So I've got 10 and then another 8. So n, the total number of data values, is 18. To find the median, I need to split this in half. This is an even number, just like we had in the last example. Because it's an even number, I know that if I were to divide all of my data values up, the median would lie here. I would have 9 values below the median and 9 values above the median. So that means that my median doesn't actually exist, but I do know that the median is between, so the median is between the 9th and 10th data value. So here I've got data values 1, 2, all the way up to 9. And on the other side of the median, I've got data values 10, 11, all the way up to the 18th data value. So my median lies between the 9th and the 10th data value. So I go up to my frequency distribution and I decide where that happens. In the first class, I only get up to the 7th data value. So data values 1 through 7 are here. In the next one, I add 3 more, which means that in this class I have the 8th data value, the 9th data value, and the 10th data value. We were looking for the median, which was in between the 9th and 10th data values, and there it is. It lies in the second class. So the class that contains the median is the second class, 20.5 to 30.5. Okay, so I'll put a box around that one too. Next, we want to calculate a mean. To do a mean here, we're actually going to be looking at a weighted mean. Because we don't have data values, we need to figure out some representative data values. And those representative data values are going to be in the form of midpoints. So I'm going to call those x sub m's. We're going to find our midpoints. It really is a mid-range. I'm going to average or find the mean of the minimum and the maximum values for each of those classes. So each midpoint is going to be the lower boundary plus the upper boundary, but I'm going to call that minimum plus maximum divided by 2. So we have 10.5 for the first one plus 20.5 divided by 2. And if I go over here and do that in my calculator, I get 15.5. That's our first midpoint. To find the second midpoint, we would repeat that and do 20.5 plus 30.5 divided by 2. That's going to be for the second class. So if I repeat that, I find a pattern, which means I don't need to keep going. So I have 15.5 for the first midpoint, 25.5 for the second midpoint. So I notice that they're 10 apart. So as I go up to my frequency distribution, I can just fill those in. 15.5, 20.5. The next one then, let's see, 25.5. And then we would have 35.5. and 45.5. I'm going to use these midpoints as representative values. So I'm going to say that I've got 7 values at about 15.5, 3 at 25.5, 2 at this midpoint, and 6 at that midpoint. So when I find my weighted mean, so let me move down here. So when I find the weighted mean, I'm just going to call it W period M period. It's going to be still a fraction. I'm going to add everything up and divide by my total, which is 18. I'm going to take each of, I'll slide it down one more time. I'm going to take each of my midpoints as a representative value and multiply it by how many I have. So I'm going to take 15.5 times 7 plus 25.5. I have 3 of those, plus 35.5 times 2 plus 45.5, just enough room, times 6. Now you can see that. To put it into my calculator, I better put parentheses around my numerator, and I'm just going to work through the calculation. Just doing these one at a time. And then I divide the whole thing by 18. I'm just going to scroll back through and make sure I typed everything in correctly before I hit enter, and it looks good. And I come up with a weighted mean of about 29 point, I got 388 repeating. I'm going to do, how about 29.4?